So I'm going to talk about how we know if P is greater than or less than alpha. So if you look at these specific areas where I have the lines, these are our cutoffs. So this is known as our critical region, these green areas. So anything that falls out in those areas are significant. So if you'll notice here, I have written P equals 0.50. So that is right down the middle where our t-test or our test statistic would be at 0. P would equal 0.50, which is 50%. Remember that 50th percentile. And also the t obtained, if there is a t obtained or t crit, would be 0. Basically meaning it doesn't deviate from the mean at all. So think about 0.50 as 50%. Now if we're looking at alpha, so this is where we would say right in the middle is where like 50% of the data would bulk up. If we're looking at an alpha of 0.05, we're looking further out in the tail. So we would be looking, maybe somewhere, let's say these are, this is where our 0.05 is, right here. Okay? Right at this location is a probability value of 0.05, meaning that 5% of the data falls here or further out in the tail. So this is basically 5% of the data. Where anything over here, between here and here, is like somewhere in the 50th percentile. It gets closer and closer to 50%. So basically, if your test statistic, so let's just say our t obtained falls, and I'm going to go back just a little, erase a couple things so we don't have so much. Well, actually, I'll keep that. So let's just say our t obtained falls right here, okay? So t equals, and I'm going to say 2.13, okay? Well, that means that it falls over here in this critical region where see that green area is. So whatever the p-value is for that is going to be less than the alpha of 0.05, because as we get further in the tail, the proportion gets smaller and smaller. That tail gets closer and closer and closer to the x-axis. That proportion is smaller and smaller and smaller. If our t obtained fell exactly right at this spot, the p-value would be 0.05. Whereas as it gets further out in the tail, it's smaller. So this is one of the reasons why I always say we can tell whether P is greater than or less than alpha just by using the distribution. So wherever our boundaries are, if our test statistic falls out here, the P is smaller. If it falls within this area here, P is greater. So I always kind of use this little example. Think of it this way. Here is your greater than or less than. So if our P is in here, in this area, it's going to be greater than our alpha. See where think of this as a mouth. It's greater than alpha. If our if our test statistic falls out in this green area, P is going to be less than alpha. So see where the arrow points this way. So always think of, okay, where does the mouth point? Where did your test statistic fall? So if we have a test statistic and it falls, here, our P is larger because it's not significant. It falls in this area that has a larger proportion. But if our test statistic, say, falls Over here, our P is less than because the proportion is out in the tail where there's a smaller proportion out in that area. So that's the way that I always say how we know if P is greater than or less than alpha. So basically, here is where you've found significance. So find significance. Oops, and I didn't spell find right. Not fang, but find significance in this area, which is rejecting the null. But in this area, okay, it's no significance. So we're retaining the null if it's within that middle area. So this is how I always know whether P is greater than or less than. P is greater than alpha if we do not find significance. P is less than alpha if we do find significance. So hopefully that makes sense. If not, please let me know and I will see if I can find other ways to explain this to you.